Okay, so today we will cover Chapter 12, which is on linear regression and correlation. Correlation and linear regression. Okay, and so this is for a relationship between, it's to analyze a relationship between two numeric variables, okay? Okay, so contrast this to, chi-squared tests where we are looking at categorical variables or a relationship between categorical variables, and ANOVA where one variable is numeric and then the other variable is categorical. For correlation and linear regression, we are looking at a relationship between two numeric variables, okay? And so generally we will designate one of the variables as x and the other variable will be y. So we have x and we have y. X is often called the independent variable, or the predictor variable, or the explanatory variable. Okay, and then y might be called the dependent variable, the predicted variable, or the response variable. Okay, and so basically a lot of the times we want to know, is there a relationship between x and y? Okay, so this might be one question. And then, and a related question is, if there is a relationship and I have the x variable, can I make a prediction for the y variable? Okay. Okay. And we have a value for x. Okay, and so as we look at kind of relationships between x and y, kind of as far as this class goes and as far as regression goes, we are going to just learn linear regression. Okay, linear regression means the relationship between x and y can be explained with a single straight line. Okay? So used can be summarized okay. And so there are other forms of regression, and then there's also multiple linear regression where you're looking at multiple variables and things of that nature. And so as far as all of that other stuff goes, you could take another entire class devoted to this topic of regression, and in this class we just get 1 week, and so or just one lecture for it. So kind of when you look at a data set where you have an x and a y variable and both of them are numeric, kind of your first question should be, is the relationship linear? Okay, so is the relationship between x and y linear? This should be kind of your first question. So this is our first question. And then the only real way to answer this is to plot the data, okay? So to answer this, okay, and so so we create a scatter plot, okay? And a scatter plot is just graphing your data as coordinate pairs. Okay, so you got, so maybe you have 1, 2, 3, 4, 5. And then so maybe you have a data point, 3, 4, and then so you'd go to 3, and then you'd go up to 4, and you'd put a dot right there. Okay, so this is 3, 4, and then maybe you have another one, 4, 4. All right, and then so that would be maybe this was not a good spot to put this. Okay, so 4, 4, etc., 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 and then so you just kind of plot these other things, and you try to decide, is there a relationship? Could the relationship here be summarized with a straight line? And then we would look at this and we would say, yeah, there it looks like a straight line could work through this. Okay, something like that. Okay, and so yeah, so this would be a linear relationship. Okay, and then as far as this class, anything that doesn't look like a straight line we would say would be nonlinear. Okay, so there could be a lot of scatter, and it could still be something like a linear relationship. So you could have something that looks kind of like this, with dots. Okay, but overall, the trend looks like something like that. Okay, overall, the overall trend can be summarized with a straight line. Although we might say, there's a lot of scatter. Okay, so this would also be linear. Okay, but then here, here's an example of something that's not linear. So we would just say nonlinear. Also nonlinear there. Okay, and so it sounds kind of silly, but yeah, your best method is to create this scatter plot and then just look at it and use your best judgment as to whether something looks like it can fit a straight line or not. Okay, so our brains are developed to kind of pick out patterns very quickly, maybe a little too quickly, where it kind of gets us in trouble. But we identify patterns very well, and so as far as at a basic statistics level, we don't have any other way that can say something looks like a straight line or not. Now there's computer algorithms that are quite complicated, and it's something. Oh, okay. Okay.